Hello everyone, my name is Kyle and I want to take you through building a blog with graph databases and in particular using Python. Although the language or the framework of the system you use is mostly inconsequential, as we're going to try and offload a lot of the work onto the database. So this is going to be a multi-part type series, and we're going to go through it step by step. And building a blog is very simple, so like what's the big deal, right? Well, the big deal here happens to be dealing with graph databases versus your standard relational database system like MySQL or Postgre. So in this part, what we're going to do is we're going to make sure we get the necessary stuff and set up our connections and basically get a template going. Nothing crazy, nothing terrible. This is mostly the primer. This is the getting it up and going so we can do the real work in part 2. Okay? So, the very first step is to grab Python and install it on your system. I'm using Windows 7 at the moment. And the next step is to grab Neo4j, which is a graph database system. Now, I recommend Neo4j because it's very easy to install and really easy to get up and running. It's probably one of the easiest graph databases to kind of jump headfirst into. And it will work across all platforms, whether you're on a Mac, PC, or Linux. So go for it. It's neo4j.com. And then, of course, set up your favorite IDE. And in this series, I'll be using PyCharm. So grab Neo4j. Like I said, this one's pretty easy. You just click download and grab the community edition. You don't need the enterprise. Enterprise comes with a lot of cool features such as replication and stuff and sharding, but nothing you'll need for this. Okay, I'm going to create a new Flask project. I'm going to stash that here in my projects directory. I'm going to call it blog demo. Now, all this little starter does is bring Flask in for me. It installs it, and does really not much else other than, some boilerplate. So the first thing I'm going to do now that I have the project set up here is going to go ahead and create that requirements.txt. And the first thing I'm going to put in here is Flask. So with the requirements.txt now written and with Flask already installed, the very next thing we need to do is install the Neo4j official Python driver. And we can do that simply by typing in Neo4j-driver. Now, my IDE is going to ask me to go ahead and install that because in case it's missing. But to let you know how to do it, it's just pip install Neo4j-driver. That's all you need to do. Okay, so with Flask installed and now the Neo4j driver and our requirements.txt are installed, the very next thing we should probably do is set up some routes. So let's build up the, let's call this index first, because there's no need to be called hello world. We'll call this one the post view. And in this one, in Flask, we do this with this. We're going to give it a slug. Whoops. Sorry, my apologies. Got a little ahead of myself. There we go. Let's just output the slug to make sure it's what we're looking for. Oh, 2 blank lines. There we go. Okay, so now we have the post view. Let's also create the category view. All of our categories will also have their own slugs. And why not, we'll even do tags. Okay, so with those running, I'm going to hit debug. I'm going to actually go to my page, hello world. Post test. Post slug is test. Category is test2. And tag is test3. Alright, so now with Flask properly configured and running, so the very next thing we should probably do is figure out exactly how we're going to deal with our data. So with that, I'm going to get you to run Neo4j. When you first run it in Windows, at least, it's going to look like this. In Linux, and I think even in Mac, it mostly comes as a command line type system, so you'll have to run it that way. But at least in Windows, it comes with this little convenient little launcher. One of the things to know about Neo is that it's a single database type system. So if you need to switch data sets or whatever, then you're going to need to create a whole new database directory. So in this case, I'm going to create a new one called blogdemo.graphdb and hit start. When you launch this, for the first time, it's going to ask you for a username and password. So you type server connect, and in our case, we're just going to go ahead and keep the default to Neo4j, Neo4j. And let's just keep it Neo4j, Neo4j. This is all oh, sorry, my apologies. Password. Alright. So, like I said, Neo4j is a graph database type system. If you haven't seen these yet, it's pretty cool. Probably the easiest way to quickly demonstrate it is to load up an example graph. And I'm just going to put in what they call the movie graph. Right. Gonna load in all that data. And so this is what a graph database tends to look like. You have nodes, such as Tom Hanks, connected to other nodes, such as You've Got Mail, connected via edges, such as Acted In. If this seems a little daunting or it seems a little strange, understand that a graph database is entirely designed around connected data, which is essentially what we as web developers try to deal with in relational database systems all the time. Whether you're using MySQL or Postgre or you name it, we have to deal with connected data all the time. A post belongs to a category and a set of tags, for example. And when you try to deal with that in a MySQL database, you tend to set up things like foreign keys. And the problem with foreign keys is that it's only a constraint. It's a data constraint for when you insert data or update data. But you have to constantly keep reminding MySQL of that relationship. So what we have done is that we have created object relational models. These allow you to interact with your relational database in a pseudo-graph style. It still has to craft complex queries in order to remind the database of the relationships that you tell the ORM about. What a graph database allows you to do is use NoSQL type ideals, schemaless ideals, and combine that with all of the power of relational data. As I can demonstrate here real quick, and then we'll jump right back in, is that we can say, hey, Tom Hanks has actually acted in a bunch of these movies, but then he's also directed some. So if we wanted to see what kind of movies Tom Hanks has directed and only get that data, we can do that. So Neo uses a query language called Cypher, and Cypher is a graph traversal language. This allows you to hop between nodes to nodes using relationships and shortest path algorithms very easily to get the nodes that you're looking for to render your page data. So in this case, I'm setting up a match query. I'm going to be looking just for person nodes, and then I'm going to return node. That brings back all of my nodes that happen to be labeled as person. And you can look at labels like tables. Down here, the blue nodes happen to be person, the green nodes happen to be movie, and you can see that represented up here between person and movie. So if we wanted to grab all movies, we just have to change the tag that we're looking for. So we have our movies and we have our person. So how do we make this a little bit more useful? I want to find out what movies that Tom Hanks has directed, right? So there are two ways of doing a very quick rare search, right? Everything is based on a JSON document in Neo. Everything is represented as JSON. Probably best described here in the text view, where actor, movie, and data happen to be represented like JSON strings. So with all the nodes only containing JSON, we can use a bit of JSON in order to query against it. So one of the easiest ways to do that is to find out, okay, so the property that contains his name is name. Okay, so name Tom Hanks. Now if I return that, I only get back Tom Hanks. Now I want to get back all the movies that he's directed. Well, okay, well, how do you get that? Okay, so what you do is you set up an edge traversal, and in this case it's represented as an arrow, right? And we'll put this as M, and we'll constrain it to just things tagged movies. Sorry, double arrow. That didn't return anything. Well, why not? Because I'm not returning M. So let's do that as well. There we have it. Now we have everything that Tom Hanks has acted or directed in. But wait, hold on. We only wanted stuff he directed. Well, that's where it gets even a little easier. So in between the arrow, we can put down, let's see, D for directed. And that's it. Boom. Now we have everything that Tom Hanks has directed. But we don't need all of that data. We can just return the movies. Look, boom. That's all the movies that he has ever directed. If we ever wanted acted in, just change the just change the edge name, and boom, we have all of the movies that he has acted in. And those are represented like your normal rows. So when you get this data back from Neo4j, through Python, through PHP, through whatever driver you happen to use, the data comes back to you as iterable rows, just like any other database. So there's nothing weird or strange about the way it handles how you get that data back. With that in mind, let's go ahead and delete everything so we can start from scratch. What you're going to notice is that it's very difficult to delete nodes that are already attached to relationships. So if we were to match everything and just go delete and go for it, you're going to get back an error. It says to delete this node, you must first delete its relationships. Well, that gets a bit daunting. So thankfully, Neo has incorporated an easy way of dealing with this. So we go match n, detach, and then delete n. Delete 170 nodes, 253 relationships, done. Now, if we try to get everything returned back in the database, whoops, we have no rows, we have no data. Perfect, clean slate, let's deal with this. Clear. Cool, so we have our Neo4j database, it's totally working and everything is kosher. I think we are now ready to deal with the data processing. I think one of the other things that we really ought to do is set up some admin stuff. We're not going to do anything weird and crazy like authentication gates or anything. I just kind of want to set up a page where I can author a post. Okay, so I have my routes all set up. To bring it all forward, I have a home page which will list out all of the available posts. We're going to use pagination via query strings. We'll do posts by slug, category by slug, and tag by slug. And those will list out the different posts associated with those categories and those tags, right? And then we have our basic admin set up here. Like I said, I'm not going to do authentication this time around, but I now have all of the routes necessary to deal with everything I can think of right now. So we have our admin landing page, we have our post list, we have our post editor for new and edit, category editor for new and edit, as well as listing and tags listing with new and edit states as well. So I think we are good to go now. So the very next thing that we really ought to do is set up a connection to our database. So Neo4j has two different ways of acquiring and persisting data into it. The first method and the most widely used method is the REST protocol. Neo4j has a fully realized built-in RESTful API type system for reading data and writing data to it underneath HTTP basic auth, if I'm not mistaken. This is a very widely used protocol by most drivers that exist, but it's RESTful API. For big applications, it can get pretty slow, but for most use cases, it's not that bad. But nonetheless, everyone can always benefit from a little bit of extra speed from the data store, right? So, a fairly new feature as of this recording is Neo4j's Bolt driver. And this is the official binary protocol that allows your app to directly connect to the database to send queries and get data back as fast as you possibly can anyways. So first things first, from Neo4j v1, import graph database and basic auth. Alright, so let's get the connection going. So we're going to set up our driver variable equals graph database.driver, and that uses the URL of Bolt localhost, and auth equals basic auth, and then your username and password. So I believe it was Neo4j, and then password is what we used. And now, uniquely, it's not quite everything you need. You need to grab the session. So driver.session. And that is pretty much everything. The only thing that's missing now is the test to see if the session actually worked, right? So we have Neo4j running, we know that. We have our basic authentication set to whatever we set the username and password to be. And then we've acquired our session here. So all we need to test now is to see if the session actually worked, right? So let's do that. I'm going to call it data, and I'm just going to go session. Session allows you to run raw queries right out of it. So now this should return no rows. There's nothing in the database to acquire. So I'm going to set up a breakpoint here. So even if data doesn't have any rows in it, I should still see some metadata about the connection and how everything worked, right? So I'll hit the debug button, and we are rocking. Refresh, and we should be in here now, and data, and it looks like everything was fine. Didn't return anything, but that's okay. Now if we really wanted to test this out, we would populate a row in there just to see what happens, right? So let's go into here, let's create and give it a label of test, and give it a document of greeting of hi there. So now if I do a general acquisition, we should see the one row returned with the greeting of hi there. So now that we have a record built into the system, now we can actually see if this thing is really returning something. So now when you run a session run, it'll do the connection, it will do the thing, but the easiest way to get back the data and use it is through an iterator. and I'll demonstrate that right now. So from here we can do a for loop, and we'll do an item in data, and for this particular example I will simply print out the greeting, and I will mark that as item. And now here's the one tricky part about using Neo, is that when you return a whole object, it will store it as a whole object for you to deal with. So multiple records can have, well, I'll demonstrate that here. Watch this. Okay, so if I went greeting, expecting this to print out just fine, it's not going to work. So if I refresh this, now despite that I know for a fact that greeting exists in the item that we're looking for, if I refresh this page, it's going to say that there's no key called greeting. But you'll see returning something called n. So that means for every record there's going to be an object, a dictionary called n that also contains our keys. So all we need to do is set it up to be n greeting. So let me restart that. Hit refresh. Seems to have worked, and greeting is hi there, just like we set in the database. It's worth it to know that these, I'm just using n as a semantic. It just stands for node. It can be absolutely anything. So the foo, return foo, and that is going to error out because there's no such thing as n, but there is foo. Right? So you can name it whatever you want. It doesn't really matter. All you need to know is that the item is sectioned into a full dictionary object. Now, it's worth it to note that you can actually flatten the data structure to return back exactly what you're looking for. So if all I wanted to do was get back, say, the greeting, then from here I can just do foo.greeting as the greeting. From here, if I wanted to use that in my system, I can just go the greeting. There it is. Greeting, hi there. So that's a very basic primer for how we're going to deal with the data persistence and retrieval of the blog items. And so that's going to be in part 2. In dealing with getting our listing views running in our admin, how to get our front page going, and then and then maybe, depending on the length of the video, we'll see if we can do a basic creation of posts, categories, and tags. Okay? All right. Thank you, and until next video.